All right, welcome to day 3 of our Unit 6A notes. The focus is on rhombus properties today. Now, a rhombus is a type of parallelogram, so it will have all your parallelogram properties that we've discussed. So, for example, opposite sides parallel, opposite sides congruent, and so on and so forth. The special thing about a rhombus is that it's a quadrilateral with 4 congruent sides. So, all the sides are congruent. So in my diagram below, I'm just going to mark all my sides congruent. Now, using both parallelogram and rhombus properties, we're going to solve for x in the following examples. So given ABCD is a rhombus, solve for each of the following, or solve each of the following for x. So if I have my picture here and I know BC is 5x plus 13 and DC is 7x minus 1, because it's a rhombus, I know all my sides are congruent. So in order to solve, I would simply do 7x minus 1 equals 5x plus 13. Okay, super easy solve. Subtract the 5x from 7x, add over the 1, and divide by 2. Now my property is that all sides of a rhombus are congruent. And that's my shorthand for rhombus, RH with a box around it. Don't say R because R will mean rectangle. So RH for rhombus. All right, next, angle D is 9x. Angle B is 2x plus 35. Now, because a rhombus is a parallelogram, that means we know that opposite angles will be congruent. So that means I can simply say 9x equals 2x plus 35. So that means 7x equals 35. So x equals 5. My property is opposite angles of a rhombus are congruent. All right, angle A is 11x and angle B is 7x. Now again, since this is a rhombus, which means it's also a parallelogram, that means opposite sides are parallel, which means if you think of AB as a transversal, that means the angles A and B are consecutive interior angles, which means they are supplementary. Now we call those consecutive angles because they're next to each other in our rhombus. So to solve this, I would say 11x plus 7x equals 180, or 18x equals 180. So x would be 10, and my justification is consecutive angles of a rhombus are supplementary. All right. Continuing on to the next page. In rhombus ABCD below, I know the measure of angle BCD, so that's this guy right here, is 116 degrees. I know that AE is perpendicular to DC, so I'll mark each of those as 90 degrees. Find the measure of DAE. So DAE is right in here. All right, so using the fact that I have a rhombus, I'm going to fill in some angle measures. Like I know that consecutive angles are supplementary, right? So that means that if this is 116, that means this little angle right here must be 64. Because again, I know that these consecutive angles are supplementary. Now if I know this is 90 degrees, that means that I can focus on this triangle right here and say that, maybe I'll call this x. X plus 90 plus 64 should equal 180 because the sum of the interior angles of a triangle is 180. When I do 180 minus 90 minus 64, we would end up with x equals 26. Now, some of you may have even noticed, okay, if this is 90, that means these two put together must be 90 degrees. And you can do a pretty quick subtraction of 90 minus 64 to get 26 as well. Now, recall that the diagonals of a parallelogram bisect each other. We talked about this last lesson. Bisects means cutting in half, so that means they're intersecting at a midpoint, and a midpoint divides. Therefore, this is going to be true of a rhombus as well. So in each of the following rhombuses, solve for x. Well, if I know that DE, which is this section right here, is 4x plus 1, and AE, which is this right here, is x plus 4, I need to be able to solve for x. Oh, I almost forgot EC, and EC is 2x. I was going to say I was about to get stuck right there. Now, because, again, a rhombus is a parallelogram, I know that E is going to be the midpoint because they bisect each other. So I'm just going to throw in some congruent markers. So in order to solve for x, I'm simply going to do x plus 4 equals 2x. So x equals 4. So you'll notice that the 4x plus 1 over here was really just a piece of information that I didn't need to solve it. All right, so likewise over here, AE is 2x plus 3. AC, which is the whole diagonal, is 3x plus 20. Now, since the diagonals of a rhombus bisect each other, that means that EC must also be 2x plus 3, because he's the midpoint. So what I'm noticing is both of these put together, so 2 times 2x plus 3, must give me the whole diagonal 3x plus 20. So let's solve. So 4x plus 6 equals 3x plus 20. Subtract the 3x to get x, subtract the 6 to get 14, so I'm getting x to be 14. Now again, what's allowing me to be able to set each piece of those diagonals equal to each other is knowing that the diagonals of a rhombus bisect each other. Okay. Okay, so another property to know about the diagonals of a rhombus is that they bisect the angles. So I'm going to use congruent triangles to help explain why this is true. Because it's a rhombus, I know all the sides are congruent. I'm also seeing that there's a shared side between these two side-by-side triangles. So based on this work, I know that triangle DAB is congruent to triangle DCB. So DAB, DCB. And that's by side, side, side. Now, if I throw some numbers in here, if angle D is congruent in each of those, that means that angle 1 is congruent to angle 2. Likewise, angle B in each of these is congruent, so maybe I'll call those 3 and 4. That means those must be congruent. And that's because corresponding parts of congruent triangles are congruent. So again, I just showed that the diagonal bisects the angle in each of these cases. All right, so on the next page. Again, I'm giving you a rhombus. I have ADB, which is this little piece right here, is 2x. BDC is 70. So again, since this is a rhombus and that's a diagonal, I know it bisects the angle. So we'll say that 2x equals 70. So therefore, x is 35. So my property used is the diagonal of a rhombus bisects the angle. Okay, ADB is 2x. Oops, labeled the wrong one. ABD is 2x. ADC is 80. Okay, so if that whole angle is 80, knowing that this is a rhombus, that means this diagonal is split into, or this angle is split into 40 and 40. Now, with that being said, I know that opposite sides of a rhombus will be parallel, so there's that Z shape. That means these are alternate interior angles. So that means in order to solve, I can say 2x equals 40, so x equals 20. So my property used to help me be able to split this in half is the diagonal of a rhombus bisects the angles. So I'm going to list that first. Now, to be able to talk about the alternate interior angles, that had to do with parallel lines. So I'm going to go ahead and say if two parallel lines are cut by a transversal, alternate interior angles are congruent. And then you're done. All right, last one in this little section. If angle 1 is x and angle 2 is 110, okay, knowing that the diagonal bisects the angle, that means these two little pieces are congruent. So let's call that x and x. Let's actually move the 110 inside. Now let's focus on this whole angle and this whole angle. Those are consecutive angles in a rhombus or a parallelogram, which means that these must be supplementary. So putting it all together, I can say 2x plus 110 equals 180, which means 2x equals 70, which means x is equal to 35. Now again, my justifications, there's two here. One is that the diagonal of a rhombus bisects the angles. And the second is the fact that I was able to use consecutive angles in our shape. So I'm going to write consecutive angles of a rhombus are supplementary. All right, there's one last little piece we got to talk about, and it has to do with the diagonals of a rhombus as well. Lastly, the diagonals of a rhombus are going to be perpendicular to each other. They even kind of look like it. So AC will be perpendicular to BD. All right, so in the diagram below, again, this is a rhombus. I'm telling you AEB, which is this little angle right in here, is 5x minus 15. Now, keep in mind, again, I know the diagonals of a rhombus are perpendicular. So perpendicular lines create right angles, which means the expression 5x minus 15 must equal 90 degrees. So add the 15 over, divide by 5, and I would get x is equal to 21. And again, my justification is the diagonals of a rhombus are perpendicular. Now, before I end, I want to talk about why that even is true. Okay, so you don't need to write down the proof, but I do want you to follow along here. Okay, I'm going to zoom in on this shape. So let's talk about why. Okay, so if you know that this is a rhombus, that means all the sides are congruent. Okay, you also know that if I focus on, let's say, this triangle and this triangle, you know there's a shared side right here in the middle. Okay, I'm going to get rid of these markers, but there's a shared side right there. Maybe I'll throw an E in there. So right at EB. Additionally, don't we know that the diagonals of a rhombus bisect each other? So that means AE must be congruent to AC. Okay, so basically I'm just showing you that these two triangles side by side, again, right here, these two triangles are congruent by side, side, side. So with that being said, if you know those are congruent, then that means these little angles, which I'll call 1 and 2, must also be congruent. If you have two congruent angles on a line, wouldn't they each have to be 90 degrees in order for that to make sense? And that's why the diagonals of a rhombus are perpendicular, because these must be 90 degrees in order for it to make sense. All right, and that, my friends, is all things rhombus related. Tomorrow we'll talk about, rectangle and square, and then we'll begin review. Your homework tonight is homework 3.